Right. So while writing recursion functions, right? So what is a recursion? Basically, when a function calls itself, when a function calls itself. So def recur, right? And now the same function, if I call recursion once, so this calls this function, and right after entering it is calling itself. So the sense it is calling itself, it keeps on calling itself and there is no end for it, and eventually it hits an error called recursion error. Yes. So whenever we are dealing with either with the while loop or with a recursion, the very important thing is the base condition. Very important thing is base condition. That is when to stop the iteratives or when to stop the recursion call. When to stop the recursion call. So we have seen here in this above example. So we had seen this, right? So we have seen this base condition here, right? We know when to stop the recursion. Yeah. So in the same way here also for writing a factorial also, you'll have to come up with a recursion, the base condition. Now tell me if we're writing a factorial program, right? What is a factorial? If I'm saying 5 factorial, 5 into 4 into 3 into 2 into 1, right? So this is our 5 factorial. Now if I am writing a factorial function, fact of n, whatever the n we can pass, it has to return that factorial, right? So regular iterative approaches, range of 1 comma n plus 1. We'll start with 1 and n. So here probably I'll keep one fact variable here, or else let me not here, but let me just create a fact variable here, which is initialized to 1. Okay, right? Fact is equal to fact into I. So eventually, if I print fact, this is going to print me the factorial, which is whatever the value. So if I pass 5, it will return 120. Now this is the iterative approach. So the same thing if I have to do in a recursive fashion. Def factorial, and I'm going to pass n to it, right? So what we are saying is, right? So return between did we look at what is return so far? Did we look at the statement? Okay, so before going to this factorial program, right, let me just explain return. Return a keyword, okay, used in functions to return certain values to caller. To caller. So for example, a simple function. So I'm calling I have a function called def add, and it is taking 2 parameters, right? And I'm saying return a plus b. I'm not printing anything. So we are calling return a plus b. So now if I am calling this x is equal to add of 10 comma 20, this will sum this value, and this is going to return. This value is going to be returned to return whoever is the caller. Now this is the place where we are calling this function, and this function is returning the sum of these two numbers. And hence, when this is returning certain value, I want to assign that value to a variable called x. Now, if I say print x, this is going to print 30. Okay. In the similarly, if I say def convert to, let us say, lower. Okay. X is equal to input of enter character or whatever, right? So what I'm saying is return x dot lower. So this is basically whatever is the function, whenever this function is being called, right? So this gives a prompt to the user asking to enter certain string. So the moment user enters a certain string, I'm taking that string and converting it in lowercase, and I'm returning that value. And I know this function will return a string in a lowercase, and I'm storing that in a variable called y. Variable called y. So now with this, what we can understand is, now whenever I say return, this function does return certain value. So how can it return? We use a keyword called return. We use a keyword called return. This is the keyword. You have to use this to return certain value. And what does that return certain value? It returns to the caller. It returns to the caller. Who is calling it? Add. So this is where we are calling this function, and we know this would return certain value, and whatever is the value that is returned, I'm storing it in a variable called x. Similarly, convert to lowercase, which this function taking certain input string and converting that to a lowercase and returning that lowercase value. And whenever I call this function, we know this function returns a certain value, and that value is basically stored in a variable called y. Right? So return, a keyword used in functions to return certain values to the caller wherever we are calling it, so that their value would be returned. So it is your choice to store it or to leave it. But generally, if a function is returning something, we would want to store that value, right? Am I clear?
Yes, sir.
Okay.
Yes, sir.
If we don't use a return statement, the default return type is default return is none, means nothing. So if a function, if we don't explicitly return anything, the default would be none. So for example, so this is not doing anything. So this is just like, printing certain string and nothing much in this. So if I call this function, right, t is equal to, if I say print t, it is going to print as none. Am I clear? If we don't specify return, the default return is none. The default return is none. If you specify explicitly what is the return, whatever is the value that you are trying to return, that value would be returned. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so now let us try this. Okay, def add a comma b. So what we are saying is return a plus b, right? X is equal to add 10 comma 20. So that function, we know it returns the value, and I'm saying print x, and let me just execute it. Right? Does it return 30?
Yes, sir.
Yes, sir.
Now what I'm printing x,
Yes,
right?
sir.
I'm printing x. Now, how are we storing value in x? Basically, when I'm calling this function is returning something, and whatever is returned, I'm storing in this variable called x, and I'm printing that variable here. Right? I'm printing that variable here. Yep. So once that variable, we print that variable. So it is basically saying, okay, this variable has this value, which is 30. Now, where is 30 coming from? This function has returned the sum of 10 plus 20, which is nothing but the 30. Are we clear?
Yes, sir.
Yes,
Clear.
sir.
Yes.
This test input. So this is something n is equal to input, enter string, whatever you enter, right? If n dot is digit, this will say, right, return number is string. Okay, is entered number is entered value is numbers number, else return value as non-numeric. Okay, so this is basically returning a string based on whether the entered value is digit or not. Right. So now I'm going to call this function is equal to test input y print x. Okay, y is equal to test input, right, print y. Okay, let us execute this. So it is basically asking us to enter string. So I'm going to enter it as 1, 2, 3. It is a digit. So this y x value should get printed as entered value is a number. Yeah. So let me just hit enter here. Does it say entered value is number? Right. So in the same way, now I'm going to enter ABC. Now it says entered value is non-numeric. So it is basically why I'm printing, right? So whatever is the value that is returned, I'm storing that value in X and I'm printing X. And the same way I'm storing that value in Y and I'm printing the Y. So whatever is the return value that is getting stored into the respective variable. Am I clear?
Yes, sir.
Yes, sir.
Okay. Now let me go back to the recursion function. So that is what return does. That is what return does. So I'm just going to comment this out. Okay, I'm just going to comment the calling portion of it. So def factorial, and I'm taking the variable as n, right? So I should call this function as far as this n value reaches 1, right? As we discussed, right? How till when I have to call this return function? Since when, till when we have to call this function? As per this logic, 5 into 4 into 3 into 2 into 1. Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Right, I will have to call this
Yes,
function
sir.
until it reaches 1. So if I'm passing 5 to this function, I have to keep subtracting one number from it, and until it reaches 1, right, we have to keep multiplying. So what I'm going to say is, if n equals to 1, I'm going to say return 1. I'm going to say return 1. If n is 1, I'll return 1. Factorial of 1 is 1, right?
Yes, sir.
Okay. Or what am I going to say? Return n into factorial of n minus 1. So basically what we are doing here is I'm calling this function again. First I call this function with I'm initiating this function call with 5. Okay. I'm calling this function with 5. Now n is 5. 5 equal to 1, true or false?
False.
False. Now what we are saying is 5 into factorial of 4. N minus 1 is 4. Right. So this now again, now let us come to this. Let's try to understand it this way. Let's build a stack. Okay. So here first we called it with factorial of 5. Yes. Now what did the function do factorial? It called 5 into factorial of 4. Right. So factorial of 4 is another function call. So that will go into another stack frame here. Now 4 into factorial of n minus 1 is what? 3.
3.
Again, if I call this function 3 into factorial of 2.
2.
Again 2 into factorial of 1.
1.
Now what happens when 1 equals to 1? What happens? We are not no more calling this function. Yes,
Yes.
it returns 1. Now factorial of 1 is 1. So 2 into 1 is how much?
2.
2. Now what are we saying? This value will be returned to, this is the factorial of 2 value. Factorial of 2 is 2.
2.
So 3 into 2 is
6.
6. So factorial of 3 value is this much. Okay, 4 into factorial of 3, which is 4 into 6,
6.
24. Factorial of 4 value is 24.
24.
Now 5 into 24 is 120.
120.
Right, there you go, you will get the output. So if I have to draw this in another fashion, so I called it with factorial of 5. What did factorial of 5 called? 5 into factorial of 4. What did factorial of 4 did? 4 into
4 into factorial
factorial
of
of 3. Factorial of 3 did 3 into
4
factorial
into
of 2. 2 did 2 into factorial of
factorial of
1.
1.
1 just returned 1 as is.
1.
Now this product is nothing but this product is nothing but this value of this. Now the product of this is nothing but a value for this factorial of 3. So what is it? 2 into 1 is how much?
2.
So the product of this is how much? 2.
2.
Right? So nothing but 3 into factor 3 into 2, 6. The product of this is 6. Now which means fact of 3 is how much?
6.
6. Now 4 into 6 is
24.
which means the fact of 4 is nothing but
24.
right. Now 5 into 24 is 120
120.
and done. And that is what would be returned. So x is equal to factorial of 5 if I say, and if I say print x, this is going to print 120.
120.
Am I clear?
Yes, sir.
Yes, sir.
Okay, now I'll try to explain it one more time, right? Factorial of 5. Oh, sorry, let me just rewrite it. Def okay, what are we saying? If n equals to 1, what are we saying? Return 1. Okay, now otherwise n into factorial of n minus 1. So if I call this function as factorial of 5, right? So this is what happens. Now what happens is I passed 5. Okay, let's understand one by one. Okay, what is the function that I'm calling? The first is fact of 5. This is the one first calling.
Yes, sir.
So n value here is what? First n value is how much?
5.
5.
5. Now 5 equals to 1, true or false?
False.
So
False.
hence it will not go into this condition. It will come to this. And this is also return n into factorial. Let me write it properly. N into factorial. The moment you say return, it will return to the caller. Okay, now what are we saying? N into factorial. When I called this n into factorial of n minus 1. What was the n value here? 5,
5.
which means 5 into fact of 4. 5 minus 1 is 4. Yes.
Yes.
Here,
Yes,
the function execution is still not completed. Now I'm once after the execution of this is completed, only then this function is completed. OK, now this is still running. Now I called fact of 4. Called fact of
4.
4. Now n value here is 4, which means n into fact of n minus 1, nothing but 4 into fact of 3.
3.
Right. So this again, this function is still not completed. This function completes only if there is a response for the fact of 3. So this is calls here n value is 3 and n is still not equal to 1. Only n equals to 1, it will say return 1. Otherwise, it will come n into factorial of what? So 3 into factorial of 2. Still it is not completed. This will get completed only when fact of 2 is completed. So here when I call the fact of 2, my n value is 2. So I call 2 into fact of, oh sorry, fact of 1. And again, this is still incomplete. This completes only when fact of 1 is completed. What is fact of 1? Right?
1.
This is fact of 3 call. This is fact of 2 call. And this is fact of 1 call. Now, when fact of 1 is equal to 1, it says return 1. Return 1. So the moment it says return 1 and it is not having anything further, right? It is not recalling it. The moment it says return, it exits the function. Exits the function. It will not go further. It's like, if you remember break, it's like exit out of the loop, right?
Yes, sir.
If you say return, it is exit out of the function, exits the function. Clear?
Yes, sir.
Okay. Now, which means this is completed. This basically returned 1. Right? So what is the fact of 1 returned value is 1. Now what does
1.
this do? Return 2 into 1.
1.
So It is returning fact of 1, 2 is returning how much? 2.
2.
So then it is no more, there is no more call further, right? So this value returned 2. So fact of 2 is basically what? 2. So this value is nothing but 2, and now 3 into return 3 into 2, 6, right? Fact of 3 is basically 6, and now it
6.
has been returned to the caller. Who is calling fact of 3? It has returned to the caller. Fact of 3, who called fact of 3? This guy, right? The fact of 3 was called by this guy, which is 6, right? So fact of 4 into 6 is 24, and
24.
we return that value also, right? And that's it. This is also been removed from the stack, right? Eventually, who called fact of 4? It is this guy. So which is 24. Now 5 into 24 is what we return. So who is calling fact of 5 here? Fact of 5 is called here, and thus it will be returned 120 as a value. 120 as a value. Clear?
Clear, sir.
Clear, sir.
Yes, sir.
So recursion is a function which calls itself, and recursion must have a base condition, must have a base condition. Without base condition, it will throw recursion error. This is our exit condition, base condition, or a termination condition.